Good evening, Dr. Riza. I'm Ivan from Group 6. I'm the MC for this presentation. Our group is presenting title about Hyatt Regency Walkway Collapse. And this is our job scope. Grayson Gan will be responsible for introduction, and Chang Wei will be presenting part on material and report, and Kheong Jie will be presenting result and discussion, and lastly, Chee Seng will be presenting conclusion. Let's start with introduction by Grayson Gan.
Hello, sir. I'm Grayson Gan. I will present the introduction for this PowerPoint. And on July 17, 1981, over 100 people are killed and other 200 some injured when two walkway collapsed within the Hyatt Regency Kansas City Hotel. At the time, a tea dance has been held within the hotel's lobby when the walkways fell. This was the deadliest structural collapse in U.S. history until the tragic event of the Global Trade Center some 20 years later. In the following article, we are going to take a look at what happened. A close analysis is out for the scope to this text. For the countdown to disaster, the Hyatt Regency Kansas City Hotel started construction in May of 1978. The 40-story building, despite some setback and delay, was opened for business in July of 1980. A major setback has the dramatically toppled down to the atrium roof when connection failed on the northern of the building. The lobby was one amongst the hotel's defining feature and include a multi-story atrium spanned by 11 walkways suspended from the ceiling. The steel, glass, and construction walkways connect the second, third, and fourth floor from north to south. Each walkway was around 70 meters long and within at around 29,000 kg, such as the look what the fourth level walkway was directly above the second level walkway. The disaster strike. All through the disaster, 1,600 people gathered for tea time at about 7 p.m. of the second level walkway had over 40 suspected. The third and fourth level walkway had about 16 and 20 people on each, respectively. During construction, a comprehensible design flaw has identified. Constructor is decided to vary the planning, which result within the double loading of the connection between the fourth floor bridge and also the atrium roof. Support beams and tie rod have been designed to carry the load for every walkway and any people standing on that. The new design change through apparent subtle was enough to critically undermine the protection of the structure. The connection dramatically failed at fourth floor and second floor bridge plugged to the atrium floor because the dust settled piled of steel, construct, and glass wrapped many bodies. Rescue team would later liken the screen to a combat area. It must terrible sight. And for the final word, the fallout has very serious responsible engineer and company had their license revoked and some even went bankrupt. compensation claim from the court award victim around $140 million to not to mention insurance payout. Disaster remains the classic model for engineering ethics and error, let alone disaster management. It should never have happened, although plan has been changed. The first design were far away from perfect. In line with the investigation, it might only have met 60% of the city prescribed code requirement. Since then, the hotel has undergone various renovation and renovation. Directly after the disaster, one walkway were reinstalled, but these points supported by columns. Aside from the third floor now being left without a connecting walkway, the lobby generally retained the original design. The Hyatt Regency Hotel is now referred to as the Sheraton at Crown Center. That's all my introduction. Thank you.
And this is some of the images during the tragedy. Okay, then next we'll have Chang Wheeler to present his material and methods.
Good evening, Dr. Riza. My name is Chang Wheeler and I'm here to presenting the materials and methods. This is the table for the calculation during the construction. The code require loading supposed to be 40.7 kips, but the actual tested ultimate capacity was 18.6 kips only. Next. This is the rope system. The draft on the left-hand side have only one nut, while the actual construction have two P on nut. Okay, next. This is the impact of the incident. The condition of people involved is it causes 114 deaths and 186 injuries. The hotel was closed for 3 months and $140 million were paid to victims and the victims' families. Okay. This is the deformation of both beams during the tragedy. Next, this is the methods we use in this review report. One of the methods used is the online research method. Information and documents regarding our topic are retrieved online from a variety of websites. Secondly, the method used is document analysis method. Textual contents found in any form of sources are studied. Data analysis also be used in this report, as the data obtained from internet is analyzed carefully to bring out trustworthy data. To top it all, the observation method is also used when doing this report. The materials from the accidents are observed to identify the causes and effects of this traumatic incident. That's all for my presentation. Thank you.
Okay, and next we'll have Kheong Jie presenting results and discussion.
Good evening, sir. I'm Kheong Jie, and I'm here to present about result and discussion we carry out in our report. After Hyatt Regency walkway collapse occurred on 17 July 1981, process of investigation is carried out to determine the information of this case. Based on the result, we can conclude few facts which are about the design of hanger rod connection, fabricator, improper inspection during construction, and the walkway is incapable to hold expected load. These factors should not occur if the construction of walkways follows standard operation procedure. Additionally, the minor collapse of action roof was occur when the hotel is under construction. This minor accident did not receive any attention from construction team, and the inspection team did not make any effort for checking it. Therefore, we can infer that the construction and inspection team of Higher Regency Walkway do not conduct their work professionally in practice of engineering. It is very terrible because it will cause engineering safety and health issues which may cause any casualty during and post-construction. Based on investigation, the final product of Hanger Road used in Higher Regency Walkway is different from original drawings on the contract. And now the slide is showing the blueprint of walkway. In the original blueprint, each hanger rod was act as continuous connector between second floor walkway to the hanger rod bracket attached to the frame of atrium roof. According to the blueprint, investigation team found out this design contributed to the collapse of Higher Regency Walkway. Jack D. Jallum, head of engineer, and his structural engineer team decided to use fragile box girder structure to make entire walkway looks fascinating. The concrete walkways along the long side of the bridge are supported vertically by two groups or I steel, which is labeled as W16 X26 on the blueprint. On the other hand, the horizontal axis of concrete walkway along the short side of the bridge is supported by the box girder, and its function is to fix the steel tie rods. Two C-beams, which is labeled as MC8 times 8.5 in the blueprint, are used to weld the box girder. A long steel tie rod that fixed to the roof is used to connect the walkways on the second and fourth floors. By referring to Jack D. Jallum and Associates' original design, the bridge joint can withstand 180 kilonewton load. However, the standard capacity of joint must be capable to carry load of 302 kilonewton without any structural problems, according to the local building code of Kansas City. The load capacity of walkway only fulfills 60% of the requirement just for the appearance effect. Furthermore, the structural team and construction team have lack of communication. Due to inconvenient to manufacture, transportation problems, and difficult to install initial design, change of design is suggested to solve problems. However, the change to design was not verified properly because the design team thought it had been tested and approved by the construction team. Then they proceeded to stamp approval seal. On the other hand, the structural team and the construction team also thought the change to design is checked and approved by the design team. This subtle change to design seems like acceptable, but it became the core factor of the accident occur. Based on post-event investigation report by Bernhard T. on 2016, it stated total death of 114 people and more than 180 people injured. This tragedy heavily affected whole Kansas City and the United States, and it caused engineering community to improve their quality as moral value of this tragedy. Nextly, it stated that the connections of hanger rod to box bin and hanger rods loads on the hanger rods during collapse were carry loads that significantly less than the required loads according to Kansas City Building Code, which is stated at the table shown in material and matter just now. And this statement showed the engineering team built an unqualified walkway that violated the construction requirement, and it caused the tragedy, although the dynamic effects on walkway will not create any significant additional load on it. Besides that, another factor is the initiator of the collapse was the fourth floor box beam connection and its hanger rods. as a moral value to avoid this kind of engineering problem. Association and Society of Engineering should implement proper inspection and verification of design for structural building. Connections of the structure should be designed properly by a qualified engineer in both design and construction process. Moreover, due to limitations of technology in 1980s, they could not apply computer programming technology into engineering. But for now, we can do it. Therefore, engineering nowadays should apply computer programming technology to all kinds of structures such as roads, bridges, and more. It can help engineers with modeling, graphing, and calculating complex math. By doing this, the risk of structural failure can be minimized and provide safer environment to public. The application of computer programming technology can check the design result accurately and improve the supervision of engineers effectively. As a result, American Society of Civil Engineering should require engineers to disclose design and structural data for protecting the public's right to know, so that this kind of accident will not occur again. Additionally, the structural engineer team can put sign at completed structure to indicate the building safety for rise of awareness about the importance of building codes. Building codes is an important guarantee to protect people's life and property. People need to be educated about the importance of building codes and should not only depend on engineering approach solution. To summarize the cause of this tragedy, it is clearly caused by the immoral behavior of design team. According to American Society of Civil Engineering, which is an organization to maintain the quality and improvement in civil engineering and humans' living standards, should act for restraining the practice and ethics of the engineer. The engineers should be alert with all their decisions because they take social contract with society, and it is possible to cause any issue that related to health and safety of public. That's all of my presentation about result and discussion. Thank you.
Okay, lastly, we will have Chee Seng presenting the conclusion of our report.
Good evening, sir. My name is Chee Seng, and I will be presenting the conclusion part in this report. First of all, this incident was mainly caused by the lack of communication between construction worker and commission building material provider. This is proven by the fact that the commission building material provider didn't get any of those calculations from the construction worker, such as the engineer and the technician involved in the accident. Moreover, the maxway of original design did not comply to the standard provided by the city. The original design of this bridge only did only around approximately 50% or less of the way required by the standard of the city, Kansas City. And later on, the change in the design made it even lower than what it originally was, which is around 30% of the original weight. Original requirement. Moreover, the whole accident could be prevented if the minimum load requirement for building in Kansas City was followed properly, which this bridge didn't. It only did around 30% of the requirement. And if the final design was checked before approval, it could be fully prevented, as the calculation of the missing calculation could be seen and could be resolved before the utilization of the bridge which will resolve the whole accident. And that's the whole conclusion I have for this report. Thank you.
All right, conclusion presented by Chee Seng has marked a full stop for our presentation about Hayat Regency walkway collapse. Thank you, Dr. Riza, for lending us your ears in our presentation. Thank you.